What is a galaxy? The question seems simple. It's a colossal city of stars, bound together by gravity, gas, dust, and billions, sometimes trillions of stellar engines, all swirling in a cosmic dance. We've photographed thousands of them. We understand their rules, their life cycles. We can predict how they form, how they evolve, how they die. But what if you found a galaxy with no stars, not a single one? A ghost, a vast, dark structure that has the mass of a small galaxy, the gas of a galaxy, but is utterly, unnervingly empty. No light, no stellar nurseries, no ancient suns fading into oblivion, just darkness. This isn't theory, this isn't speculation. Recently, NASA's Hubble Space Telescope confirmed the existence of the very first object of its kind. They call it Cloud 9. And its existence changes everything we thought we knew about galaxy formation. The story of Cloud 9 begins not with a picture, but with a signal. In the early 2000s, radio telescopes conducting a deep hydrogen survey detected something unusual, a massive, isolated cloud of neutral hydrogen gas floating in the void near the beautiful spiral galaxy Messier 94, about 14 million light-years away. At first, it seemed unremarkable. Orphaned gas clouds aren't unheard of in the universe. They're often debris, remnants of galactic collisions, tidal tails stripped from passing galaxies, or leftover material from ancient star formation. Cosmic litter, essentially. But this one was different. It wasn't small, it wasn't faint, it was enormous, holding enough raw material to build millions of stars like our Sun. In fact, it contained roughly 50 million solar masses of hydrogen gas. That's more than some small dwarf galaxies. And it wasn't orbiting anything. It wasn't being pulled apart. It was just sitting there, stable, isolated, ancient. The big question was, were there any stars inside it? Was this a hidden dwarf galaxy shrouded in gas, too faint for previous surveys to detect? Or was it something else entirely? To answer this, astronomers needed the sharpest eye we have, the Hubble Space Telescope. They pointed it directly at the heart of the cloud, searching for any sign of stellar activity, young blue stars, old red giants, anything. And what they found was just as important as what they didn't find. Nothing. Absolutely no young, massive, or even old stars. No star clusters, no supernova remnants, no planetary nebulae. The detection limit was incredibly sensitive. If there were any stars brighter than our Sun, Hubble would have seen them. It was a dark, empty ghost. For the first time in astronomical history, science had confirmed a new type of celestial object, a starless, gas-rich, dark matter-dominated cloud, a failed galaxy, an embryo that never developed. But here's where it gets even stranger. Cloud 9 isn't just sitting in empty space, it's part of a larger cosmic structure. Messier 94, the spiral galaxy it orbits at a distance, is surrounded by a faint halo of similar hydrogen clouds. Most of them are smaller. Most of them show at least some signs of star formation. But Cloud 9? Nothing. It's as if the universe gave it all the ingredients to become a galaxy and then just walked away. So if it's not a galaxy, what is it? The official term is RELHIC, Reionization-Limited HI Cloud. The name itself is a clue to its origin, but what it means is far more fascinating. Think of it as a cosmic fossil, a relic from the universe's infancy, preserved in a state that shouldn't exist today. Cloud 9 has two main ingredients. First, a vast reservoir of neutral hydrogen gas, the primordial fuel for star birth. This is the same material that filled the universe after the Big Bang, before the first stars ignited. It's cold, dense enough to collapse under its own gravity, and yet it hasn't. But the second ingredient is the most important, an enormous, invisible scaffold of dark matter. Dark matter is the hidden architecture of the universe. It doesn't emit light. It doesn't interact with normal matter except through gravity. But it makes up 85% of all matter in existence. Every galaxy we see, including our own Milky Way, is embedded in a massive halo of dark matter. It's the gravitational glue that holds everything together. Cloud 9 has one of these halos. Astronomers estimate it contains roughly 10 billion solar masses of dark matter, about 200 times more than the visible gas. This dark matter halo is what keeps the hydrogen cloud stable, prevents it from dispersing into space, and should, by all rights, be triggering star formation. But it isn't. Why? To understand that, we need to go back 13 billion years to a time when the universe looked very different. In the early universe, this dark matter halo began to pull in gas, just as it should. It was on the path to becoming a normal galaxy. Hydrogen gas flowed inward, cooled, began to compress. In a typical scenario, this process would eventually reach a critical density and the first stars would ignite. But then something happened. The universe itself turned against it. During an era known as the Epoch of Reionization, roughly 400 to 1 billion years after the Big Bang, the very first massive stars and quasars exploded into existence. These weren't ordinary stars. They were monsters, hundreds of times more massive than our Sun, burning at unimaginable temperatures. And when they died, they didn't go quietly. Their radiation flooded the cosmos with intense ultraviolet light. This cosmic blast was so powerful that it ripped electrons off neutral hydrogen atoms across the entire universe, turning the once dark cosmos transparent for the first time. It was a phase transition on a universal scale. For most proto-galaxies, this wasn't a problem. They were massive enough, dense enough, that their gravity could hold on to the gas despite the heating. Star formation continued. But for smaller systems, systems like Cloud 9, the timing was catastrophic. The intense radiation superheated the gas within Cloud 9's halo, giving it enough energy to resist gravitational collapse. The gas couldn't cool, it couldn't compress, and without compression, stars couldn't form. It was frozen in time, a galactic embryo that never got to be born, a skeleton of a galaxy made only of its dark matter bones and a thin shroud of gas. And for 13 billion years, it has remained exactly that way. The discovery of a single failed galaxy is fascinating, but its implications are profound. Why is this object so important? Why does it matter? First, it's a perfect laboratory for studying dark matter, one of the biggest mysteries in modern physics. In a normal galaxy, the gravity of stars and gas complicates our measurements. When we try to weigh a galaxy's dark matter halo, we have to account for the mass of billions of stars, dense gas clouds, supermassive black holes. It's messy. There are uncertainties. But Cloud 9 is pure. It's almost entirely gas and dark matter. No stars to confuse the signal. No complex dynamics to untangle. By studying the motion and distribution of the hydrogen gas, which we can map precisely with radio telescopes, astronomers can weigh the invisible dark matter halo with unprecedented accuracy. It's, as one scientist put it, a window into the dark universe. We can test our theories of dark matter in a pristine environment. We can measure how dark matter clumps, how it holds gas, how it influences structure on small scales. These are questions we can't easily answer by looking at normal galaxies. Second, Cloud 9 is likely not alone. These objects are incredibly faint and almost impossible to see. We only found this one because it's relatively close, 14 million light-years is practically next door in cosmic terms, and because modern radio telescopes are sensitive enough to detect its hydrogen emission. But cosmological simulations predict that hundreds, maybe thousands of these dark galaxies should be drifting through the cosmos, completely invisible to us. They're the missing pieces of the galactic census, failed galaxies that never made it past the embryonic stage. We may have just found the tip of a cosmic iceberg. And third, and this is perhaps the most unsettling implication, Cloud 9 forces us to confront a disturbing question: how much of the universe never got to exist?
Think about it. For every galaxy we see shining in the night sky, how many proto-galaxies were still born? How many potential galaxies were stopped in their tracks by cosmic radiation, by timing, by bad luck? How many civilizations, how many worlds, how many stories never happened because the universe shut them down before they could begin? Cloud 9 is a monument to cosmic failure, a reminder that the universe we see is not the only universe that could have been. There's one more twist to this story. Recent follow-up observations suggest that Cloud 9 might not be completely dead. Deep radio imaging has revealed faint, irregular structures within the gas cloud, density fluctuations, filaments, clumps. They're not stars, but they're something. Some astronomers believe these could be the stirrings of delayed star formation. Perhaps after 13 billion years, Cloud 9 is finally cool enough, dense enough to begin collapsing. Perhaps in another few million years, the first faint stars will flicker to life inside this cosmic ghost. Or perhaps these structures are something else entirely. Echoes of interactions with Messier 94, tidal disturbances, or effects we don't yet understand. We don't know, and that's what makes it so compelling. The universe is filled with objects that follow the rules. Stars are born, galaxies grow, clusters form. It's a natural, predictable process. We've mapped it, we've modeled it, we understand it. But every now and then, the universe shows us something that broke the rules, an anomaly, a glitch in the cosmic code, a ghost of what could have been. Cloud 9 isn't just a failed galaxy. It's a direct message from the dawn of time, showing us how the universe we see today was built and what was left behind in the process. It's a reminder that survival in the cosmos isn't guaranteed, that even galaxies can fail, that the universe is littered with the fossils of things that almost were. And sometimes the most important discoveries are not about what we find, but about what isn't there.